once again, we have 3 statements here. And your goal is to figure out which of these statements are true. And it might be more than one of them. And I'll give you a little bit of time to do it. All right, let's go through each of these one by one. So the first one right over here, an object moving to the left. So let's draw some object, and it's moving to the left. So it's moving in that direction right over there. Must have a leftward force acting on it. So does it have to have a force that is acting on it towards the left? And we didn't even talk about net force or balanced force or unbalanced force. It's saying it must have a leftward force acting on it. Well, we know from Newton's first law that if this object is moving at a constant velocity, it's moving at a constant velocity to the left, there doesn't need to have any forces acting on it. In fact, if no forces act on it, or if there's no unbalanced forces acting on it, or no forces at all, it will just continue to move to the left. So an object moving to the left does not have to have a leftward force acting on it. If there was an unbalanced net, or if there's a net leftward force acting on it, it would accelerate towards the left. But you don't have to have one. If it already has some velocity in the left direction, it can just keep going there without any forces at all. So this is not true. You don't have to have a leftward force acting on it. Second statement, a tennis ball is thrown upward by a boy on Earth. So let's say that this is the tennis ball. So let me draw it. This is the tennis ball. It's just left the boy's hands. It's thrown upwards. So the tennis ball, once again, it's going in the upwards direction, just like that. Once the ball has just left the boy's hand and is traveling upwards, so this is the situation that we're talking about, the net force on the ball is also upwards. So let's think a little bit about all of the forces that are on the ball. This ball right here, it's near the surface of the Earth. It's going to have the force of gravity acting on it, or the force of Earth's gravity pulling on it. So you're going to have the force of gravity. You're going to have the force of gravity pulling down on it. And is there going to be anything that is going the other way? And we can think about something like air resistance, but let's just assume that that's negligible, especially relative to the force of gravity pulling down on the ball. And so we see here the only major force here, especially if we ignore air resistance for now, and air resistance is also going to be going in the direction opposite the ball, so it'll really just also go in the downward direction because the ball is going to be bumping into things as it moves upwards. So we see all of the net forces on the ball, or actually all of the forces on the ball, or all the major forces on the ball that we're talking about, are actually in the downward direction. And that's why, remember, forces they're not directly impacting, they are impacting velocity, but F equals ma. F equals ma. When you have a net force in a given direction, it accelerates in that direction. So here we have a net force in the downwards direction. It's going to accelerate the ball downwards. Or another way to think about it, if the ball is already moving upwards, it's going to decelerate the ball, which is exactly what we know in everyday life experience. You throw a ball in the air, it is moving upwards right when you throw it, right when it leaves your hand, but it's going to slow down, come to a stop, and then start falling again. And the whole time, it is being accelerated downwards, or while it's going upwards, you could say it's being decelerated in the upwards direction. So this over here is also false. The net force on the ball is actually downwards. Third statement, a sled is traveling to the left and slowing down. So let's draw this sled. So maybe the sled looks something like this. A sled is traveling, so it's traveling to the left, and it's slowing down. So it's decelerating in the leftwards direction. The net force on that sled must be directed to the right. This is absolutely true. The net force, if the net force here is acted to the right, then the acceleration will also be acted to the right. And if you're moving to the left and your acceleration is to the right, you are going to be decelerated, or you are going to slow down in your leftward direction. So the only statement that was true here was statement 3.